So now we're getting into something that's supposed to be a little bit more difficult, and this one's has a bit extra that we need to go through. It's really not that bad though. So we have the R be the region enclosed by y equals x cubed over 2, the line y equals 4, and the y-axis. And you can see that y equals 4 is right here. That's where it stops. It's also stopping at the y-axis. And so the region R is the base of the solid. For each y value, the cross-section of the solid taken perpendicular to the y-axis, so we are perpendicular to the y-axis, is a rectangle whose base lies in R and whose height is y over 2. This is pretty similar to our past example. So we have a rectangle perpendicular now to the y-axis, so it's going to lie like that. So you can picture a rectangle. I'm much better at drawing these rectangles. And so that rectangle, let's think of its area real quick. So we know that its height is y over 2. And now its length is actually, it can't be y equals x cubed over 2, because remember the length here is going to be equivalent to whatever the x value is. So what we want to do with that, how we're going to deal with that is let's just go ahead and take that y equals x cubed over 2 and solve for x. So I'll multiply the 2 to their side, 2y equals x cubed. And so we get the cube root of 2y equals x. Because we want it to be this horizontal distance, because that would be the length of our rectangles at horizontal distance. So it's actually the cube root of 2y. So remember earlier when I said this one has a little bit of a tricky part to it, that was it right there. So now what we have to do, we're just going to set up and we're not going to integrate, so that's kind of nice. And they also gave us the bounds. We're going, our lower y value is 0, our highest y value is 4. So we're going to integrate, we're perpendicular to the y-axis, so everything should be in respect to y. And look, our function, a of y, we already found it, is in respect to y, so we're good there. So I'm going to do the integral from 0 to 4 of the cube root of 2y times the y over 2. And so that's going to be in respect to y. So remember right there, this is the area of the rectangle because this is the base times the height is this one. So this may not be a possible multiple choice answer in Khan because they might simplify this up a little bit. So let's just go ahead and take a look at that. So I'm going to split up, since this is multiplying, I can split those up. Cube root of 2 times the cube root of y times y over 2. Honestly, that 2 on the bottom, I'm going to go ahead and pull to the front along with this cube root of 2. Might as well just bring out all those constants. And so we have y to the 1/3 times y to the 1. So we have our y to the 1/3. Let me just highlight that. That's y to the 1/3. And this is our y to the 1. And so we add those exponents. Forgot my dy. We add those exponents. Cube root of 2 over 2. Integral from 0 to 4 of y to the 4/3. And from there you can finish out the integral, but we don't need to. We're just supposed to set this one up.